Okay, in this video we're going to have a look at some key properties of acids and alkalis and in terms of indicators and how we tell them apart. Okay, so the first thing at the top here, you notice there's a pH scale going from pH 1 to 14, and then underneath I've allocated the type of chemicals that would fit this pH scale. So this end of the pH scale we know goes from 1 to 6. This is where my acids are. At the lower pH values, these are my strong acids, and at my higher pH values in here, these are my weak acids. And remember, strong and weak describes how well the acids separate, split, and the chemistry word for that is dissociate. If you're not sure what that means, watch the video on acids and I'll explain it to you. In the middle here, pH 7, we've got neutral, and then at this end, 8 to 14 are going to be my alkalis. Remember, alkali is a soluble base. And these, again, this end here, closer to 7, these are my weak alkalis, and here are my strong alkalis. And again, we use the word strong and weak to represent how they dissociate or split. Strong ones fully dissociate, weak ones partially dissociate. We also need to know some color changes in here. So litmus, when we use litmus solution in these, we get acids, it turns a red color. In alkalis, it will go blue, and in neutral, it will go purple. Okay. We've then got methyl orange as a second type of indicator. So this will go red in acidic pHs, and it will go yellow everywhere from neutral all the way up to the pH 14 for the alkalis. And the final indicator we need to know about is phenolphthalein. And phenolphthalein is colorless. So it's colorless in acids all the way up to neutral. And then in alkalis, it will go pink. The other key thing to be aware of here is, if you remember about our acids, we can measure the hydrogen ion concentration for these. And at the bottom of your page, you have these hydrogen ion concentrations written down for you. And you can see here, this has got a value of 1 times 10 to the minus 1. So this is a very high concentration of hydrogen ions. And as you work your way up, this becomes 1 times 10 to the minus 14. This is a much lower concentration of hydrogen ions, which you'd expect, because this end is going to be our bases, our alkalis, which are going to have less H+, down to hardly any, and here we're going to have a higher concentration of hydrogen ions because these are my acids. The thing to bear in mind is if I go down to pH number 1 here, and if I increase my pH by a factor of 1, then what has happened here is my hydrogen ion concentration has decreased by a factor of 10. So this is reduced by a factor of 10. And do it again. So go from 2 to 3. The pH increases by 1, and this will decrease by a factor of 10. So a change in pH of 1 has a factor of 10 in terms of the hydrogen ion concentration change that we see here. That should hopefully help you to complete that page and also to explain some of the questions at the bottom of the sheet with your responses.